Okay, a very good afternoon to all of you. Today we shall solve some small problems based on what we have learned this week. Okay, so here is the first question, and I will first ask you whether you have any suggestion how you would like to solve this. Okay, so can you see the question?
Yes, sir.
Yes.
Yes, sir.
So, any suggestion? We have to find the Norton's equivalent circuit between the nodes X and Y. Okay. So, one way of doing this is to simplify this circuit recursively or iteratively. So, first maybe we consider this portion of the circuit, okay, and consider these two terminals 1 and 2. So between these two terminal, how much is the Thevenin voltage and Thevenin resistance? Thevenin voltage will be, so we have a 5-volt source and 5 volt connected in series. So if you apply potential divider rule, then between this node and this node, if you call them A and B, how much is the voltage between A and B? It is
2.5.
2.5, excellent. 2.5 volt. And how much is the resistance between A and B? When you remove this 5, again 5 volt, 5 ohm, 5 ohm in parallel is equivalent to 2.5. Okay, so this is 2.5 ohm in series with 2.5 volt. This is between A and B. Now let us consider say this part. Okay, so we have one more 2.5 volt and one more 2.5 ohm, and this is 2.5 volt. Okay, so if I call this terminal as terminal C, this is again B, so then between C and B, what do we have? In total, we have 2.5 plus 2.5, 5 volt and 5 ohm. Okay, so this is what we have between C and D, C and B. Okay, and then and this is 5 ohm. And then finally we have one more 5 ohm connected here. Okay, so this is X, this is Y. How much is the Thevenin voltage between X and Y?
So this is again same as between A and D.
Yeah, so again, so this is finally this will be 2.5 volt in series with 2.5 ohm. Okay, and this is between X and Y. Now this is equivalent to, if you do a voltage practical voltage source to practical current source conversion, so how much will be the Norton this current source current? That is 2.5 by 2.5, 1 ampere in parallel with 2.5 ohm resistance. This is X, this is Y. Okay, so finally what will be the answer then? How much is what is the Norton's equivalent circuit? Basically this is the answer. This is the Norton's equivalent circuit. 1 ampere current source in parallel with 2.5 ohm resistance. Okay, any question?
Sir, can you repeat how we got the A and B part, like between A and B?
Yeah, so between A and B, what do we have? 5 ohm, another 5 ohm, here 5 volt. Here is A, here is B. So and when we are finding Thevenin voltage or Thevenin equivalent of any part or any circuit, then outside we will not consider anything to be connected. Okay, so outside nothing is there, and at that moment, how much is the voltage between A and B? How much is this current? This current is 5 by 10.
0.5.
Okay, 0.5. And then how much is the voltage between A and B? Then VAB will be
5
5 volt. Okay, this side plus,
into
this
point.
side minus.
Oh,
Okay.
yes, sir.
So is it okay now? Who asked this question?
Yes, sir.
Okay, fine.
Yes, sir. Yes, sir. It's clear.
Okay. So shall I move to the next question
It will be
or
2.5.
yes?
VAB will be 2.5.
PA, oh, yeah, 2 point, thank you, thanks a lot, 2.5 volt, yeah, absolutely right, yeah. So moving to the next question. Okay, now in this circuit, here we have the resistance R, this is variable, and we have to find the maximum power that can be transferred to this resistance R. So how do we proceed? Once again, if you call this terminal say as X and this as Y, okay, let us find the Thevenin equivalent of between X and Y. Okay, so we have here X, here Y, this is 5 ohm, 5 volt. Oh, here also there is a 3 ohm minus plus 6 volt, 2 ampere and 5 ohm. So this is the circuit, and between X and Y we have to find the Thevenin circuit. Okay, so let me first make a copy of this and gradually simplify this circuit. Okay, so first consider this portion which is colored in blue. What is the equivalent of this portion, this blue portion? Can I say that this is equivalent to only
2
this
ampere constant. Current
only this
source.
6 volt source and nothing else? Okay, because how much is the resistance between this is X and if this is A, how much is the resistance between X and A? That is 0, right? So essentially this is equivalent to this. Okay, next let us consider say this portion which I have drawn in red. Now can you find the equivalent of this red portion?
Yes, sir. 10 volt and 5 ohm series.
So that will be 10 volt, 5 into 2, 10 volt and 5 ohm in series. Okay, 5 ohm and this will be 10 a voltage source, 10 volt. Which side plus, which side minus? Lower side plus.
Upper side minus upper side.
Yeah. Okay. So now, then I think it is easy to simplify it further. So now this is another copy. Okay, so I'm going in this way. Now this 6 volt and 10 volt, they can be clubbed together as one single source of value 16 volt. Okay, like this. So you may also write it in this way, plus minus, and here minus 16 volt. Okay, now can you tell me how much is Vxy?
5.5 volts, sir.
It will be basically average of 5 volt and minus 16 volt. Okay, so Vxy.
Sir, but here, don't the plus will be down, right, sir? 6 volt and then we would subtract, right?
Uh,
16
yeah, so
because
Sir, can
in
you
this 16 volt,
how you got rid of the 3 volt, 3 ohm resistance?
no, sir. What
No,
I
no,
was trying to say was that
yeah.
this plus should be down for 16 volt.
No, here I have
Plus
minus
shouldn't
here.
be down.
You see, I have minus 16 written outside. Okay,
Oh, right.
yeah. So, so basically, this voltage at X will be exactly halfway between 5 and minus 16. So that is minus 5.5, right? So that is the voltage. And how much is the Thevenin resistance between X and Y? R Thevenin between X and Y is
2.5 ohms.
2.5 ohm. Okay, so if so, then what should be the value of this resistance R for getting maximum power? R should be equal to 2.5 ohm for maximum power. And then how much will be the power when R is equal to 2.5 ohm? Power in resistance R will be basically I square R. How much will be the current? I, that will be V Thevenin by R plus R Thevenin, square of this multiplied by R, and R is equal to R Thevenin in this case. Okay, so now if you put the values, V Thevenin is 5.5, so 5.5 squared, R and R, this is 5 squared, here 2.5. Okay, so how much that will be? Can you see?
3.025.
3.025. This is in watt.
Sir, while calculating the R Thevenin, wouldn't we consider that 3 ohm resistor also?
No. See, 3 ohm. This 3 ohm resistance actually is a false dummy kind of resistance, because I mean when you consider this blue part, okay, so the equivalent of this blue portion is just this source alone. 3 ohm is not there because I mean if this between X and A the resistance is 0 because 3 ohm is in parallel with 0 resistance of the source, and anything in parallel with 0 is equivalent to 0.
Alright, got it, sir.
So any question in this? Yeah?
So while calculating Vxy, why does 5 minus 16 by 2? Why there is 2 in the denominator?
I just have used potential divider rule. So you assume, for example, here this point to be the reference point here. Y is the reference point. Then this is 5 volt here, left side, and this right side is minus 16 volt. Okay. Now you apply potential divider rule, and you have equal resistances. So that's why. Should I elaborate it more? Hello?
Yes, sir. Can you elaborate more?
Yeah, sure. Okay, then let me do this. So we, suppose we have two sources, call them V1, V2, and resistances R1, R2. Then, how much is the potential between A and B? We have done this in class. VAB will be
V1 by R1 plus
R
V2 by
plus
R2
V2
by
by 1 by R
1 by
Right.
R1 plus.
okay, and then if R1 is equal to R2, then this will just become V1 plus V2 by 2 if R1 is equal to R2, right? And now you compare this circuit with this circuit. So basically we have two sources, two resistances. That's all, right? They are same circuit, na? And this R is
got
not
it,
there.
sir.
Yeah. Fine. So any question here in this? Any more? No? Okay, fine. So let me then move to this third question. So we have to find the Thevenin voltage VAB. This is A, this is B. This is 6 ampere, 10 ohm, 10 ohm, 10, 16, plus minus, this is 5. Okay, you first try and then I will do it. Okay, you first try. Okay, so let us do it in this way. First, consider say this portion. Okay, what is the equivalent of this? A
35, sir.
yes, 30 volt in series with
30 volt and 5 ohms.
5 ohms. Okay, then after this we have one more 10 ohm. Okay, so let me just add 5 and 10 and make it 15. And then here is node A, here is node B. Achha. Then let us consider the left side. What will be the equivalent of the left side?
8 volt 5 ohm.
So
10.5.
yeah, so it will be a 5 volt source, sorry, not 8 volt source and 5 ohm resistance.
Yes, sir.
Okay, now it is very easy. So how much will be VAB?
2 volts.
So I can write in this way, VAB will be minus 30 by 15 plus 8 by 5 divided by 1 by 15 and 1 by 5. This is in volt. How much is this?
1.5.
Minus
1.5.
minus 1.5. Yeah, it should be minus because this 30 by 50, 30 by 15 is larger than 8 by 5. Okay, So any question here? Anyone?
No, sir.
Okay, so let me move to the next question. Okay, this is very easy, so I would expect you to try this first. So what is given is that VA, this is VA minus VB. Okay, this voltage is 6 volt. So that means here we have 6 volt, left side plus, right side minus. We have to find VC minus VD. VC is here, VD is here. Okay, so between these two nodes, okay, how much is the voltage? VCD is how much from here to here. So any suggestion how you will proceed?
Sir,
Yes.
sir, as you can see, if we consider since it is divided in three squares, the leftmost square, if we see there is, I think, 3 ampere current leaving on the top side.
Acha, okay, let me do it. Let me do it. Sorry. Okay, so
Sir,
in the
it can be
top
1
side,
volt.
let me see. So in the top part, how much is the current here? If this current is I is 3 ampere.
Yes, sir.
Acha. If so, can you tell us how much is the current here?
3.
It should be same as I, right? Because if you consider any part of the circuit, say for example this part, there shouldn't be any accumulation of current. So if I amount of current is entering this part, the same amount must come out. So this is I, and if this is I, then if this current is I1 through 1 ohm resistance, then how much is I1?
5.
5.
2 plus 3, 5 ampere. Okay. Now if that is 5 ampere, then VCD will be minus 5 ampere into 1 ohm. So that is minus 5 volt. Okay. Fine. Now let's move to another question. We have to find the Thevenin equivalent circuit between P and Q. Here is P, here is Q. Okay. Anyone has the answer? Repeat. Please repeat.
5 ohms and 5 ohm and 4.
Yeah, right. So if you consider, say, only this part, this is just equivalent to only the source alone, 4 volt alone. 20 ohm is a dummy resist. Not significant in this question, this 20 ohm. And then we have 10, this is 4. So now simply apply potential divider rule. So the voltage VPQ is half of 2 volt, half of 4 volt, so that is 2 volt, and R Thevenin will be 10 parallel 10 ohm parallel 10 ohm, that is 5 ohm. That was actually very easy. So let us move to another question.
Hello, sir.
Why
Yes.
was 20 ohms not
Yes, sir.
important?
Why was 21 is
Yeah, so okay, let me call this A and this B. Okay, so between A and B, what is the Thevenin equivalent between A and B? How much is the Thevenin voltage between A and B?
4 volt.
4 volt. And how much is the Thevenin resistance between A and B?
0.
0. So that's what we have drawn here, 4 volt in series with 0 ohm, right? So this 20 ohm is not,
sir? Why 0 ohm?
because acha, what is the R Thevenin between A and B is how much? This 20 ohm in parallel with 0, 20 ohm in parallel with 0 ohm, because the internal resistance of a voltage source is 0, right? And so this will be how much? 20 into 0 by 20 plus 0, that's 0.
Yes, sir.
Okay.
Okay, sir.
So again Thevenin voltage between A and B, Thevenin voltage and resistance. So I think you can do this. So first, how much is the Thevenin resistance between A and B?
2.4.
2.4.
So that is basically 6 parallel 4.
Sir, 5 volt.
Let me do this. Yeah. So 6 parallel 4
7
is
volt.
6 into 4 by 6 plus 4, that is 2.4 ohm. And now to get the voltage, okay, so acha, you can apply the this rule which we have used earlier, this thing V1 by R1, V2 by R2 whole divided by 1 by R1, 1 by R2. So this is one way of doing this. Another way may be like this. Say for example, if I take this as the reference node, okay, then this point is at 5 volt, and then so acha, then let me first find this current I. How much is I? Equal to 10 volt minus 5 volt by 10 ohm. Okay, 6 ohm plus 4 ohm. So that is 5 by 10, 0.5. Okay, ampere. Now if so, then yeah, now this point is at 5 volt, then what is the potential at this point? Here, that will be 5 volt. So this is node A basically. So VA will be 5 volt plus 4 ohm into I, that is 5 plus 4 into 0.5, which is 7 volt. Okay.
So we can also
Any question? Hello?
no, sir. I said that we can also do it by source transformation.
Yeah, that's also possible. Yeah.
Sir, the voltage, Thevenin voltage should be 5 volt, right? Between A
No,
and B.
7 volt, because see, VA is 7, VB is 0. So how much is VAB? Basically Thevenin voltage, that is 7 volt. 7 minus 0.
Sir, here we in the place where we're finding I, the current, there we are assuming that the current through 6 ohm resistance and 4 ohm resistance would be same amount of current,
Yes,
right?
yes. That has to be, na, because there is no other path. This has only
Li-
one one loop. Okay, so all this current must be same, right?
okay. But if something is connected between A and B, then it would be different. The
See,
current.
no. The point is that when we are
Hmm.
finding the Thevenin voltage, that is basically open circuit voltage. So that means nothing is connected between A and B. Okay, so Thevenin voltage
Okay.
is just by definition it means the open circuit voltage. Okay.
Yes.
Okay. So now we have to find a Norton's equivalent of this circuit. Okay. So you first try and then I will also do it. So first considering this portion, so this portion is equivalent to 3 volt in series with how much is
1.5 ohm.
1.5.
1.5 ohm. Yes, sir.
Yeah, and then uh, this this so- uh, this source you consider. Okay, so this is equivalent to a how much 3 into 2 6 volt and 3 ohm. This is A, this is B. So now we are done. So that means this is equivalent
9 and
to uh, 9 volt in series with 4.5.
2 ampere and 4.5.
Yeah, so then this is equivalent to 9 by 4.5 is 2 ampere and 4.5 is in parallel 4.5 ohm. A and B. Okay. Any question here?
Sir, once you can show the before question, like you have taken like zero resistance and did once show that, sir. I was getting confused.
In an earlier question, this
Yes,
one,
sir. You took like a zero resistance and you did
this
parallel.
one, right? This question.
Yes.
Yeah.
Okay, sir. I got. Okay, sir. I got.
Okay, fine. So then let us take another question. So here we have to
Sir,
find.
will you just show the previous question?
Yes, I will. This one, right?
Oh, okay, sir. Thank you, sir. Done, sir.
Now here we have to find VPQ. Okay, this here is P, here is Q. So VPQ is from here to here. Let me take this side plus, this side minus. We have to find VPQ is how much. Okay, we have two sources, one current source 2 ampere and this is 10 volt voltage source. So how do you propose this should be easy to solve? What do you think?
We can use superposition problem.
Very good idea. So let us use superposition. Very good. So let me first take the current source, and then what should happen to the voltage source? It should be replaced by
By wire.
short circuit. Yeah, right. This is 2, this is 4, this is 8, this is 6 ohm, this is, here is P, here is Q. So here in this circuit VPQ is how much? This is 2 ampere. Okay, how much is the total resistance between P and Q? R PQ is how much? That is
4 ohms.
6 parallel 4 plus 2 parallel 8. This is in ohm. So this is 2.4 plus 1.6, absolutely right, 4 ohm. Okay, so how much will be VPQ then? It will be
8.
8 volt.
8,
8 volt.
8 or minus 8. See, this is how I have taken VPQ, right? Left
Yes, sir,
side.
minus 8.
Yes, sir, minus.
So minus 8.
Minus 8.
Yeah. Then next, sorry, control G.
So how did you get minus 8? So again, we have to take resistance in series, right, with the battery.
Which resistance? So I have taken all these 4 into
No, but then
consideration.
again, we'll take the 8 volt in series with the 4 ohms, right?
8 volt in series with 4 ohm. 4
Yeah,
ohm
when
is
we
already
current,
considered, na?
Voltage,
Yeah, so actually I have, I possibly should have written it this first and that later, because okay, now hopefully this makes more sense. Okay, so left side first, then right side. Okay, so now consider then another situation when we have only the voltage source plus minus 10 volt and the current source is
Open circuit.
opened. Yes, open circuited. So now now what will happen? How much will be this right side current? That will be 10
1.
by 10, 1 ampere. And how much is the left side current?
1.
Again 1 ampere. Okay, so now here VPQ in this case will be 2 ohm into minus 1 ampere plus 4 ohm into plus 1 ampere, that is 2 volt, correct? Okay, so therefore finally total VPQ will be minus 6 volt. Okay, minus 8 plus 2 is minus 6. Is it okay? Fine. So
Sir, won't it be minus 2?
which portion?
Yes, sir, it should be minus 2 volt VPQ
In the
in
right.
the third figure.
But
VPQ, this rightmost circuit.
yes, sir.
So we are considering basically voltage drop from left to right. Okay, so voltage drop from P to Q. Okay, so this then should be first this 2 ohm multiplied by the current that flows from left to right from P to Q. And how much is the current from P to Q? That is minus 1, right? And then across this 4 ohm, we have 4 ohm multiplied by the current that flows from left to right, which is 1 ampere. Okay, so then this comes out to be plus 2 only, na? Is it fine, or please?
Yes, sir.
Yeah, I think there is no calculation mistake here.
Yes, sir, it is plus 2.
Yeah. Okay, so now this is the next question. We have to find this current I here, this current. How can we solve? Let us use Thevenin's theorem once again. Okay, so let me first redraw this circuit without this 2 ohm resistance. So we have this, and and then we have another branch. Here is another 1 ohm. Okay, this is 1 ohm, this is 1 ohm, 1, 1. Okay, let me call this terminal A, terminal B. So here is terminal A, and here is terminal B. Okay, so the 2 ohm is connected between A and B. Okay, so that we haven't drawn because we want to find the Thevenin equivalent between A and B. Okay, so can you tell me how much is the Thevenin voltage between A and B? Anyone? Okay, so suppose if I consider this as the reference node here, then how much is the voltage at node B? This is 5.
2.5.
So this is 2.5 volt. And how much is the potential at node A?
2.5.
So how much is the Thevenin voltage between A and B?
0.
0.
0. So now we have to find the current I which would flow when we connect this 2 ohm resistance here. So we
So how did you say?
pardon?
So how 2.5?
How 2.5? Which one? VA or VB?
Anyone.
Anyone. Okay, fine. So consider. So this is not there now. Okay. Consider. So this point, call it C. How much is C? C is 5 volt. Okay. Then from C, go through this black path. Okay. So we have two 1 ohm resistance in series, and then it is connected to ground. So how much is this current here? This is 5 by 2,
Okay, got it.
2.5 okay, ampere and so on. So basically A is just halfway between the 5 volt and 0 volt. So that's why 2.5 volt. Okay. So is it fine? Acha, so how much will be the current I when you connect this? It will be
0.
0.
0.
Yeah, we don't need to calculate the Thevenin resistance since the voltage is 0, no matter how much is the resistance, unless, I mean, this current, no matter how much is the resistance, this current will be definitely 0. Okay, once again, another Thevenin voltage you have to find. VTH between, call this A and B. You have to find V Thevenin plus minus. So you please try first.
क्या मतलब है?
Please repeat.
14 is
14. I think 14 is absolutely right. Okay,
Yes,
good,
sir,
very
14.
good. Yeah. So how do we do this? So first, consider.
Yes, sir,
say-
14.
Yeah, very good, excellent. Let's consider this part. So this is just equivalent to one 4-volt source and nothing in series, 0 resistance in series. And then we have this 2 ohm outside. Okay, this is 4 volt. Okay, then here is the current source, 5 ampere. Here is 3 ohm, A, B, okay. Achha, now how is this circuit going to behave? So how much will be the current in different branches? Okay. There is only one current which is here, 5 ampere, because of this current source. Okay. And through this 3 ohm resistance nothing is flowing, so across 3 ohm resistance there is no voltage drop. Now if you consider this as the reference point, 0 volt, then this point is at 4 volt. Okay, then this point above this current source will be at 4 plus 10. So the voltage drop across 2 ohm resistance is 10 volt, right side plus, left side minus. Okay, so this is from here to here. Okay, so if I call this C, node C, then VC is equal to 10 plus 4, 14 volt. Okay, and across 3 ohm resistance there is no voltage drop, so VAB therefore will be equal to VC equal to 14 volt. Okay, fine. Now,
Sir, where did that 3 ohm go? Was that the same concept about dummy resistance that you taught?
No.
Or
3
something
ohm
else?
is there, but through this there is no current flowing, right? So there is no voltage drop across it.
Sorry, sir, but your voice is not audible.
Please mute yourselves. Yeah. So now the current through the 3 ohm resistance is 0 ampere. Okay, because there is no closed path for the current to flow. Okay, so there is no voltage drop across it. Okay.
No, sir, the one parallel to 4-volt battery, I was asking about that.
Oh yeah, this 3 ohm. Yeah, right. I mean, this is a false one, doing nothing, because let me call this terminal as what can I call this? D, and this is so this is B here. So how much is the Thevenin voltage between D and B? That is 4 volt. How much is the resistance between D and B? That is 0. Right?
Yes, sir.
So that's why this 3 ohm is not of any significance. It's not of any significance. Okay, so let us solve one more problem. Possibly this is the last problem today. So we have to find the value of this resistance R, for which the power in this load will be maximum. This is 6 ohm, this is 3 ohm, this is 10 volt. Okay. This is the last question today. So what should be the value of R for maximum load power? Yes?
Sir, 6.
2
sir.
6, sir.
Anyone else?
Sir, 0.
Excellent, excellent. Okay, suppose if
Yes,
I call this current I, okay, then how much is load power? Load power is just I square into 3 ohm. Okay, now to maximize this load power,
maximize current.
what we have to do, we have to maximize this I square or I, we have to maximize this, okay, because 3 ohm is just a constant. So to get maximum load power, we should get maximum I. Now to get maximum I, what should be the value of R? R should be
0.
as low as possible, 0 ohm, okay, because the lower the value of R, higher will be I, okay. As R decreases, I increases. So therefore 0 is the answer. Okay, fine. So this is already 5 o'clock. So let me stop here today. And
Sir,
yeah.
sir, I had a doubt.
Yes, please.
You said R decreases and I. So like if I keep R as 3 ohm, then the net resistance would be 5 ohm and the I would be 2 ampere. While if I
Yes,
keep
sir.
R at 0, then the net resistance will be 9 ohm and the current will be 10 by 9. So
Okay,
Yes,
actually,
let
as
me
it is parallel, so
yeah,
higher the R,
wait.
lesser
So
will be the
if
resistance,
R is
lesser will be the current.
if R is equal to, you're saying 3 ohm, right?
Yes,
Then
sir.
how much will be I? Then I will be 10 volt
2 ampere.
divided by 3 ohm plus 6 parallel 3, right? How much will be this?
Yes, sir.
This is 10 by 3 into 3 plus 3 into 2 third, 3 plus 2. Okay, so this is 2 ampere. Okay, now if R is equal to 0 ohm, then I will be 10 divided by 3 plus 6 parallel 0. So that is how much? 10 by 3 ampere. So this is 3.33. Okay, so we are getting more current.
Okay, okay. Yes, sir, yes, sir.
Okay, fine. So let us stop here.